All right, welcome friends. The moment we have all been waiting for. Our students are now going to be introduced to using the algorithm, which is a more efficient way oftentimes for adding numbers. Okay, so we're still on this same standard. Math, grade 3, number sense and operation, standards 2, and benchmark is 2.1. All right, so we have a problem here. The school library is getting new books. They received 3,182 books in the first shipment and 2,413 books in the second shipment. How many did they receive in total? Well, what you want to do when you introduce this lesson is look at both, look at partial sums first, because we want students to make that connection between partial sums and using the algorithm. So we would have 3,182 plus 2,413. So if we're using partial sums, 3,000 and 2,000 is 5,000. 100 and 400 is 500. 80 and 10 is 90. And 2 plus 3 is 5. So we get 5,595. Now, method 2 is the algorithm. Make sure students are comfortable and familiar with that word. An algorithm is just a rule that we use for carrying out a particular math operation. We're going to have them for fractions and for multiplying, for dividing. So we're going to use the algorithm. We add by place value starting with the ones, move to the left. So we have 3,182 and 2,413. All right, I like having these side by side so they can make these comparisons. Now, another thing to really help students and instill place value in them. I know our habit, the way I learned it, the way that I taught it for many years, is just add the numbers. 2 plus 3 is 5. 8 plus 1 is 9. 1 plus 4 is 5. Let's work on using place value language. We've got 2 ones and 3 ones. That gives us 5 ones. We see it over here in our partial sums. We have 8 tens and 1 10. That gives us 9 tens. Use that, that verbiage instead of just saying 8 plus 1. And then say, well, how do we see the 9 tens? Well, I see it right here in the number 95. 9 is in the tens place. 100 plus 400 is 500. And then 3,000s and 2,000s is 5,000. It's going to really help reinforce place value. Now, obviously, an algorithm can be a more efficient way of adding numbers. Sometimes there's strategies that mental math is easier. But ask your students when you look at these two side by side, how is the algorithm similar to partial sums? Okay, another thing you could do here, there are several different math language routines. I believe they're out of Stanford University. It's research-based routines to help your students be able to verbalize and talk about math instead of just working problems. So this is a great time to use the critique, correct, and clarify. So students rewrite a math response from an example that is incorrect, incomplete, or otherwise ambiguous. The example I have falls into otherwise ambiguous. So maybe we have a student showed the sum of 146 and 31 as 456. So here is the math response that they're rewriting. Justine said the sum is incorrect because the students didn't line the numbers up correctly. Ask students to work with their partner to improve Justine's response. So this one is a very ambiguous because it just says didn't line the numbers up correctly. So it's not wrong, it's just ambiguous. So have your students work together. What we're hoping that they talk about is the place values, that they don't have those place values lined up correctly. So have them work with their partner to rewrite this response that is more clear about the problem with the student's work. So a good opportunity, I think, to use that math language routine in your classroom. All right, my friends, thanks for joining. We'll see you in another lesson.